Hi, everyone, and thank you for joining today. I'm really excited, and I have a big light in my eyes, so I can't really see your faces, which is good. Um, our topic for today will be advanced attack vectors in Azure environments. Uh, Unfortunately, I was supposed to present it with my colleague Bill, but he had some passport issues and can't really came to the US. So his part of the session is recorded, and we will see it later on. So sit tight, and I hope you will enjoy the session. So before I begin, who are we? So both me and Bill live in Israel. My name is Zur Ulianitzky. I'm the VP Research at XM Cyber. My colleague is Bill Ben Haim. He's a security researcher in the team. We have a vast experience in penetration testing, red teaming, and actually a lot of research areas. Actually, Bill and myself met each other when we were young and practiced judo. We both were in the Israeli national team, and Bill used to beat me all the time. But now I'm his boss, so we're in a good shape. So our agenda for today will start with some Azure fundamentals in order to better understand the different topics we will touch today. We will continue and talk about initial foothold, possible ways to gain into Azure in tenants. We'll continue and talk about two main use cases, each one composed from multiple and different abuses within Azure environment. We will continue with best practices and some cool bypasses to different Microsoft security measurements that are set in place within the Azure tenant. And we will finish by introducing XMGoat. Perfect. So I will start by talking about some Azure fundamentals. I won't elaborate a lot about it because the couches look really good and I don't want you to fall asleep. But I will only touch on the ones that are really important in order to understand the topic today. So whenever we're talking about Azure in general, there are two main services that are important to understand. The first one is called Azure Active Directory. I guess most of you are familiar with it. And the second one called Azure Resource Manager. In general, Azure Active Directory is where you manage all the different identities and principals within the Azure tenant. Those can be users, groups, applications, service principals, managed identities, and so on. And within Azure Resource Manager, you usually manage different infrastructure services provided by Microsoft, such as virtual machines, storage accounts, databases, and so on. It is important to understand that there is a high coupling between Azure Active Directory and Azure Resource Manager. This can be seen good in this diagram, where in the top we can see the Azure Active Directory service, who actually everything is associated to it within Azure Resource Manager. So whenever you are applying any type of permissions, you are doing any type of assignment within Azure Resource Manager, those are applied to Azure Active Directory principals who managed there within the tenant. There is a really common attack vector where you can abuse a user that has the global administrator role definition within Azure Active Directory. And you can actually elevate your permissions and get a role assignment of the user access administrator role definition within Azure Resource Manager. Using this role definition actually allows you to create a new role assignments within Azure Resource Manager and actually compromise and get your hands on any type of resource within Azure Resource Manager. Perfect. So I will continue and talk a bit about the permission model in Azure environment. And I will begin with the resource manager. As you can see in the picture, role assignments within Azure are actually composed from three different main objects. The first one is called the security principal. And this can be a user, a group, a service principal, and a managed identity. Within the role assignment, the security principal is actually present to who we are going to assign the permissions. The second object is called role definition. And role definition is nothing more of a set of permissions that you allowed to do and not allowed to do. In this example, we can see the contributor predefined role definition. And we can see that the contributor role definition has all the different possible permissions that exist within Azure Resource Manager. This can be seen in the action section in the image. And we're removing some authorization permissions, as you can see in the not actions section within the role definition. The last object is called scope. And actually, scope is to where we are assigning the permissions and where those permissions going to be valid. There are 4 different types of scopes that you can define within Azure Resource Manager role assignments. The first one, and this is the bottom one, is actually the actual resource that you have been created. So by using it, you can assign permissions directly associated to a specific resource, such as storage account, a database, and so on. The second type of scope can be a resource group. So within Azure, whenever you create any type of resource, you must define the resource group who is going to host that resource. The next possible scope is called a subscription. Usually, you are assigning your billing account per subscription, but in terms of role assignments and permission, this is just another layer that you can decide on within the scope. And the last one is called the management group, and this is just another top level kind of scope that you can define within Azure, who usually hosting everything below it. In general, it is important to understand that whenever we're assigning a permission, the permission will be inherited down to all the different scopes that we decided. So in this example, we can see that the marketing group received the contributor role definition on the pharma sales resource group. This means that anyone who resides within the marketing group will receive the permissions on the pharma sales resource group and any kind of resource that have been created and set within that resource group. The next permission model is Azure Active Directory. As I said, those are Azure Active Directory and Azure Resource Manager are completely different services. They have a lot of similarities, but some differences as well. So in terms of permissions, it's really similar. You can see that we're again defining 3 different types of object, a security principle, a role definition, and a scope, where the scope is a bit different this time, where you can define the scope to be a tenant, an administrative unit, or a specific Azure AD resource. In addition, there is a big difference between the maturity of those permission models, where in Azure Resource Manager, you can create any type of custom role that you would like with any kind of permission. And within Azure Active Directory, you can't really do it, and usually you're going to use the predefined ones. So I'm pretty sure some of you are familiar with global administrator, application administrator, and so on. Perfect. So I'm promising I'm done with some fundamentals. In general, the different use cases that we will see today are starting with the assumption that we are somehow could get our hands on some type of credentials or identity. So I just wanted to go over some basic ways in order to gain the initial foothold towards Azure environments. So the first and the most common one is by using some social engineering attacks, such as phishing, brute forcing, and password spraying. This will allow us to get our hands on some credentials of users and then abuse the different permissions attached to them. The second possible way is by exploiting a vulnerability on a public-facing service, such as virtual machine. This will allow us to abuse an identity that is attached to that public-facing resource in order to do and start doing our lateral movement within the Azure tenant itself. Another possible and really common way is by actually buying some compromised accounts in the dark web. Those are pretty cheap and sometimes also MFA claimed, so even conditional access or any type of MFA set in place can be bypassed using this type of method. Azure actually have a CLI tool that you can use, which is called AZ CLI. Whenever someone is using that CLI, it is storing locally on the machine on default paths. It can be a short-term access tokens of users and clear text secrets or certificates related to applications. So if the attacker has access to the internal network of the environment, it can locate those kind of files, extract the credentials, and then get the initial foothold. Microsoft did a really good job integrating on-prem domain environment and Azure Active Directory. This is done by using AD Connect, which I will elaborate in the next slide. But in general, you can abuse those features in order to get your initial foothold. So one of the typical ways to do it is by abusing hybrid environments, where the same device is connected both to on-prem domain controller and Azure Active Directory. And having a foothold on those kind of machines can allow us to generate PRT tokens that will allow us to get our initial foothold into the environment. In addition, there are more capabilities that you have set in place within Azure AD Connect utility, and you can abuse different types of SSO features in it in order to get the initial foothold. Perfect. So, as I said, Microsoft created a tool named AD Connect. The main purpose of this tool is to synchronize on-prem domain environment toward Azure Active Directory. This synchronization actually going to sync different type of users and groups that are located in the on-prem domain controller to Azure Active Directory. In addition, using this tool will allow you to authenticate using the same on-prem users to Azure Active Directory. And authentication can actually be done using 3 different types of authentication methods. The first and the one that Microsoft recommends to use is password asynchronization. This type of authentication is actually synchronizing the on-premise NTLM hashes of the users to the cloud. And then all the different authentication and authorization validations are being done in the Azure Active Directory side. But there are many organizations that don't want or can't do the synchronization and take outside from the internal network the credentials to the cloud. And because of that, Microsoft added 2 different type of other authentications. The first one is called pass-through authentication. And whenever an organization is using this type of authentication, once the user entering his credentials, those are being sent to the domain controller, to the on-prem domain controller, and this is the one who does the validation of the credentials. And obviously, you can use ADFS in order to do the authentication. Later on the talk, during a build recording, we will show a nice abuse of the pass-through authentication agent, but we will get to it. Perfect. So we prepared 2 different use cases today. The first one is called from external user to sensitive data. And for every use case, we will start by showing what we configured in the environment in order to do it. So the prerequisites for this one starts with an Azure AD user with some reader permissions. In addition, we configured and set in place an Azure Active Directory application with some Microsoft websites permissions. Those permissions will allow us to compromise a function app later on. So obviously, we also need to have a function app set in place. And in addition, we will assign to that function app a user-assigned managed identity, and we will give to that identity some permissions over Key Vault that will allow us to read and get some secrets, and over some storage accounts that will allow us to list storage account containers, storage account themselves, and blobs, and also read the files within them. So this is a nice diagram we created that represent all the different types of things that we will do in this use case. We will start in the left side with the specific user. As I said, everything in this session is assumed breach, which means the attacker was able to get his hands on a specific user. Then, after some enumeration, the attacker will do, he will be able to understand that he has some owner permissions over an application, and abusing those owner permissions will allow him to reset the secret related to that application and then authenticate as the application. Then the attacker will do some reconnaissance with the service principal associated to that application, and he will be able to understand that he has the permissions to add an SCM user to the function app, and I will touch later about what is SCM. And with some more enumeration and reconnaissance, he will be able to understand that the same function app has a user-assigned identity attached to it, and because of that, he can generate an access token for that identity and abuse it for an additional lateral movement in the environment. And then the attacker will be able to read some blobs. The blob will be a protected zip file, and the protection password will be stored in the key vault, and we will see how we can enumerate and get our hands on the secrets and the sensitive file. Perfect. So the attacker received or bought, doesn't really matter, a user. And then he starts to do his reconnaissance in the environment. Most of the things we will show in this lecture will use the AZ tool provided by Microsoft or some random REST request that you will see later on. So the attacker actually starts by using the azad uplist command. This command lists all the different applications that have been created within the tenant. Doing so will reveal multiple applications. And the next things that the attacker would like to do is to check if he has ownership on any of those permissions. This can be done by using the azad app owner list and passing the ID related to the application that we wish it for. And we will see that one of the applications in the tenant actually owned by John user, who is the user that we are using right now. Perfect. So the next thing that we're going to do is to add a secret to the application. This can be done by using the azad app credential reset command, which will create in response a new password or secret related to the application. The next thing that we can do is authenticate as the application and check if the application has any more permissions set in place. So we have been authenticating with the application. And the next thing that we want to do is to do some reconnaissance within the Azure Resource Manager. So anything you saw till now was against the Microsoft Graph API, which is the one who is behind Azure Active Directory. And from now, we are going to do some reconnaissance in the Azure Resource Manager. So the first thing that we would like to recon is if our application has any role assignment attached to it. This can be done by using the AZ role assignment list command and providing the application ID. And as we can see, the application have in place a role assignment. The role assignment is on a specific subscription, which means that all the permissions are related to that subscription and any type of resource created within that subscription. And the role definition represented within that role assignment called function app editor. And the next thing that we want to do is we would like to use the AZ role definition list command in order to see what are the kind of permissions we have been in place related to this application. And this will actually reveal that the application has the function app editor, a role definition as we saw earlier. This is a custom role definition, which means someone, which was me, created it behind the scene in place. And we can see in the action section of the permission that we have some permissions over the Microsoft web provider, which is the one hosting the function app APIs. So the next thing that we would like to do, we would like to exploit the function app. And in order to do it, we need to see if the function app actually has any type of function set in place. So by sending a REST command towards the Microsoft website's endpoint, we'll reveal that there is a function created within the function app named XM function that we can try to exploit later. The kind of exploit that we're going to do is adding a publishing user to the SCM panel. But before that, we need to understand what is the SCM panel. And actually, SCM is the administrative interface related to function apps, app services, and logic apps, which is automatically created whenever you provision a new service, which is one of those. Behind the scene, the SCM is an open source tool called Kudu. So you can also check the code and what it does behind the scene. And actually, an attacker that has access to this administrative panel can execute some operating system commands on the infrastructure hosting the function app. You can harvest some secrets, some passwords, some sensitive data from it. And most importantly, you can actually generate new access token related to the identities attached to this function app. So the next thing we want to do is we want to exploit the SCM panel and the permissions that we have. This can be done by sending this post request that actually contains within the body another put request that the backend going to send. This put request will be against the publishing user's endpoint that you can see in the end. And within it, we're going to generate a new SCM user. His username going to be attacker xm12345 with some password. And as the result, we will receive an HTTP 200 status code that actually says that the user have been created, and now we can try and authenticate with that user to the SCM panel of the function app. This will actually allow us in the diagram to continue and jumping from the service principal that we created the password to into the function app. So we will surf using our browser to the SCM default URL, and with some basic authentication, we will authenticate with a newly created user. And now we are residing within the infrastructure hosting the function app. And we will start and do some more enumeration in order to do if the function app has any user assigned identities attached to it. Because if we do have it, we can try to create an access token to those identities and then abuse their permissions and do some additional lateral movement in the environment. So this can actually done by sending the GET request to the site's endpoint and passing the XM function, which is the name of the function app. And we can see in the response that actually the function app has a user assigned identity attached to it. The name of the identity is keyvault underscore storage account underscore reader. And there is the client ID related to this identity. The next thing that we will do, we will create a PowerShell script that we will run on the using the SCM panel with the user we've just created. This script is going to create an access token to the identity that the function app has behind the scene. So running this PowerShell script will create an access token that we can then use and continue our lateral movement with this identity. The next thing that we want to do is to create another PowerShell script in order to do some more reconnaissance. So we will start by doing the reconnaissance and listing if there are any storage accounts in the environment. Within storage account, you usually store some containers and blobs within it, which is the equivalent of the S3 bucket that I'm sure everyone here is familiar with. So this can be done by sending the following GET request to the storage account endpoint. And as a result, we can see that there is a storage account in place named super secret stuff XM. We will continue and do some additional reconnaissance on that storage account to check if there are any containers set in place. This can be done using this PowerShell script, which will send a GET request to the containers endpoint within the function app, within the storage account. And we can see that there is a container named secret, and we can now try and check if the container has any type of blobs within it. So we will continue and create another PowerShell script that will send another GET request that will list all the different blobs within the container. This will actually reveal that there is a zip file stored in the container named for authorized only, and we will try to get our hands on this zip file by using the following PowerShell script that will query that specific blob. And this is good. So we executed the PowerShell script, we received the blob within it. Then we will try to access the file, and we will see that it has some password protection, and we have different type of things that we can do now. We can try to brute force it and get this file within the zip file, and we can search in different key vaults and secret management services within Azure in order to see if any of them is stored over there. This is pretty reasonable because it is stored within Azure's storage account, so we can try and search for it. So we will do some more enumeration to check if there are any key vaults in the environment. This is similar to the previous command, and I won't elaborate a lot about it, but we will see that there is a key vault name secrets, and that key vault actually has a secret named secret for zip encryption, which sounds good to me. And once we will try to get the secret, we will be able to see that there is a value of the secret. And using that value, we'll reveal and open the zip file, and we will be able to get our hands on the sensitive file. Perfect. So now I will play the recording of Bill part. It will show you the second use case and some best practices securing Azure environment, and I will come back at the end.
Hey everyone, and thank you for joining us. My name is Bill Ben Haim, and I'm a security researcher in XM Cyber for the past 2 years. My current responsibilities are the topics of Azure Active Directory, Azure Resource Manager, and now Google Workspace. But enough about me, let's continue for the second use case, a low privilege user to a tenant takeover. So, we're starting by explaining the attacker flow. In this case, it's a bit more complex since we have two different initial footholds. One on the Azure Active Directory AD Connect password authentication machine, and the other one is the cloud user account that the attacker obtained. So the attacker obtained the user account and then starts a reconnaissance on the functional. Discover that he has the permissions to generate a JSON web token and modify SCM IP security restriction in order to access and gain control over the SCM administrative panel. He then uses the identity which is attached to that functional. This identity gives him the permissions to add a password to any app registration within the Azure AD tenant. The attacker found that he has an application with permissions to change any user authentication method. This is a great permissions for the attacker. He then uses the password authentication on-prem machine to abuse it and combine with the app registration permission, gain control over a global administrator user account. Let's see what are the prerequisites for this second scenario. So we need a user account with a custom role that has the following Azure Resource Manager permissions. Next, we need an app registration with the following Graph App roles. We need a managed identity with a Cloud Application Administrator Directory role, which is attached to that functional, and a password authentication AD Connect configuration. Great. So we are starting by enumerating the attacker obtains a user account called low privilege user. Then enumerates his current role assignments and discover that he has SCM FW updater role definition name. So the attacker needs to know what are exactly those permissions. So enumerates this role definition and discover that the actions of that role definitions allows him to do some manipulations on the functionals or sites. This custom role definition is scope is over the subscription. So the attacker doesn't wait and tries to directly access the API and execute commands over the SCM, since he has the correct permissions to generate a JSON Web Token. But unfortunately, the attacker cannot access it, saying the web app is unavailable. Then the attacker starts and enumerates the current configuration of that function. The attacker then discovers that that function app has security and IP security restriction over the SCM administrative panel. This blocks him from accessing the SCM from anywhere and any IP address in the world. So then the attacker starts and the attacker gets or access the current SCM, gets a 403 forbidden access. The attacker then changes the current SCM IP security restriction from denied to allow, meaning that anybody now that has the correct credentials to access the SCM will be able to access it from anywhere in any IP address. As you can see, the attacker can now successfully access the CUDO or SCM administrative panel of that functional. And right now, we are in this scenario, we are in this specific spot. Next, the attacker enumerates the current function for managed identities and discover that he has a user managed identity called function of identity. Then he enumerates the role definition of a cloud application administrator and discovers that that role definition indeed has the ability to change any application owners. The attacker then continues to enumerate the current role assignments that has the role definition ID of the cloud application administrator and discovers that the function of identity, which is attached to XM function 2, has that role definition ID or that role assignment. Great, so now the attacker has the ability to change any application password by adding himself as the owner and changing the credentials of that password or adding a password credentials to that application. Now he needs to find a suitable target. Currently, he found an application called change of method. The attacker then checks the graph upload permission of that application and sees that he has the user authentication method .readWriteAll. By Microsoft, this current graph upload permissions will allow the application to read and write any authentication method of all users in your organization without assigning a user. Authentication methods include things like a user's phone number and authenticator app settings, but not only. This is extremely powerful permissions that will allow you to change many other user authentication methods. This restriction or this attacker lists the current change of method app owners. And he sees that the owners of that application is currently test user account. The attacker then uses the cloud application administrator permissions to generate a JSON web token, add it to the authorization header within the HTTP request that you can see right now, and add the app ID of the application and the object ID of the user account that he wants to add to the application as owners. Once the application was successfully sent, and we can see that when enumerating again the owners and listing the owners of that application, you can see the low privileged user. Great, so currently we're at this spot in the scenario. Now we need to find a suitable target, right? The attacker needs to find a suitable target. Since we have the passive authentication AD Connect configuration, we have a foothold in that machine. We need to find a way to see if there are any synced enabled users. So we found that David student xmlabs.net user principal name is a synced user account. We then enumerate the global admin role definition ID using this GET request. And we can see that this is the ID of the role definition ID of the global administrator role. The attacker lists the current global administrator role assignment using the principal ID of David's account. And we can see that David has the global role definition of a global administrator, meaning this will be our target, or the attacker's target. So right now, we found a way to change any authentication method. We found a user target, a user account that we want to add as a target. Now we need to use the password authentication abuse, our second foothold, in order to get these current credentials. So Adam Chester, or XPN 2 or 3 years ago, was able to do a short POC over password authentication abuse. Password authentication is a type of configuration of the AD Connect hybrid authentication. First, he injected a DLL injection into Azure AD Authentication Agent Service process. Then he used the trampoline function in order to hook the logon user W Win API. By hooking this Win API, he was able to backdoor any user account and log in with the word or specific string, in this case, the word hacked, without knowing the actual password of that user. Let's see a short scenario, a short POC. So currently we're at the machine, our second foothold. We can see that we are part of Zur directory, the name of the tenant. In this case, we're seeing that David user account is a synced user account. We can see his user principal name. Then we are looking at the assigned roles, and we can see that he has the global administrator role, as we just saw in the HTTP request. And then we have a look at his current authentication methods. He has an email account and a phone number. So let's start the actual POC. We use the system informer to see any loaded modules into that process, the Azure AD Connect Authentication Agent Service. And you cannot see any malicious DLLs right now. We then use a simple program in order to inject our malicious DLL using the PID of that process, 505740. We can then check again the properties and go to the loaded modules, and we can see the backdoor hook.dll is successfully loaded or injected to that process. So now we see the short POC. We first have a char trampoline, an array. We then have the Boolean function, logon user hook, and then we have an if statements that says if password credential is equal to hacked, always return true. This means that when the attacker will try now to access David's user account from the same machine, with the string hacked in the password field, you will be able to bypass those restrictions and see that the current text or authentication method, as we saw before, it ends with 44. So now the attacker needs to change the authentication method of that user in order to bypass this restriction, right? So he enumerates the current authentication methods and sees that he has the phone number and the email address, as we saw before in the POC. Next, the attacker uses a page HTTP request in order to change the current phone number to his controlled phone number, and was able to change it successfully. Now the attacker can successfully log into the Azure portal as a global administrator role. Great success. Let's see a short POC of it. So the attacker goes back to that machine, logs in again after changing the authentication method phone number of David's user account, enter his current VPN and the current password hack as we did before. And as you can see, the end of the number is 46, the controlled attacker's phone number. He then receives the current code, the one-time password, to his phone number, enters that phone number or that code, and can now successfully access the Azure AD as a global administrator account. Meaning that that user can now control over all the Azure AD tenant and the Azure Resource Manager. Great, so we found and were able to use it to get the global admin. What are the best practices for security? Next, first is logs. Use any type of log to enumerate and detect weird behaviors in your Azure AD environment or your Azure Resource Manager environment. Activity logs, network logs, Azure AD logs, which contains Azure signing logs and audit logs, resource, DNS, and application logs. Next, the concept that we all know. A least privilege refers to an information security concept in which a user is given the minimum level of access or permissions needed to perform its job functions. For example, use custom roles and not built-in roles. Be specific when defining actions. Stop using the wildcard sign. Always use a whitelist approach and not a blacklist approach. And last one is to limit the role assignment scope. Next, we have a type of service called PIM. PIM right now is deployed it's a service that is deployed in Azure Active Directory and Azure Resource Manager. It helps you manage, control, and monitor access to important resources or roles in your organization. Provides just-in-time privileged access to Azure AD and Azure resources. Time-bound access to resources using start and end dates. Require approval to activate privileged role. And enforce multi-factor authentication to activate any role. What does it mean? So in the assignments, we have two types of assignment types. We have two types of assignments. The eligible assignment and the active assignment. Eligible assignments means that you can request in the time-bound access that they gave you a request for an approval or request to access a specific role. Active means that automatically it will be activated. But in PIM, or Privileged Identity Management, when defining a role or the default configuration of Azure AD role, in this case the global admin role, does not require you to approval in order to activate. As we just saw in this scenario, Azure MFA and Azure AD connection access maybe also can be bypassed pretty easily with the right permissions. It's crucial to do the correct configuration and not to use the default one. Now we have the conditional access. At the simplest, there are if and then statements. If a user wants to access a resource, then they must complete an action. For example, a user that wants to access an on-prem machine needs to be enforced by an MFA. But if the user wants to access the cloud apps, he doesn't need to put any MFA or he doesn't have any restriction. Conditional access policy can be configured to deny access from different locations, different countries, different range of IP addresses or specific IP addresses, different sources or different targets, such as devices, users, groups, roles, and many, many more. Same as PIM, we have two ways to control it. We have the graph upload permissions, which will let you to read, change, and delete every conditional access. In addition, there are two different roles, Azure Active Directory role, called Conditional Access Administrator, or a custom role with the following permissions that will let you to change and delete or create new conditional access policies. Thank you very much for that. I hope you enjoyed. Now Tsu is going to show you the XM Goat and our new added scenarios to that XM Goat. Okay.
Perfect. So I hope everyone enjoyed this kind of abuses within Azure. If you liked the different type of abuses to function apps, we have released a blog about 10 different ways to compromise function apps. Each one abuses different types of permissions that you can actually configure within Azure Resource Manager, and you can use the link below to see it. Perfect. So about a year ago, we released a tool named XMGoat, which is an open source tool with the purpose of teaching about how to attack and protect Azure environments. XMGoat is composed from different scenarios. Each scenario is a Terraform script that you can deploy in the environment, which will provision a vulnerable environment. Each one of them has different use cases that you can do. And we created two additional new scenarios and we released them today. So you can go to the GitHub, see them, and obviously, if you want, you can contribute and add more scenarios. It will be awesome. So the first scenarios that we created actually start with the user. Using that user, we can generate JWT tokens, just as Bill showed you before, to the SCM panel of a function app. Then we can abuse the identity attached to that function app in order to add the password for different application. This is due to the fact that the identity has the application administrator graph role assignment attached to it. Then one of the applications in the environment actually has an application permission that allow you to create new graph role assignments in the environment, and you can create a new role assignments to the user that we started with and assign it with the global administrator permissions. The second use case is the one that I showed you earlier, where we're starting with a user that has owner permissions over a specific application. Then we can authenticate to the application and publish a new XML user to the SCM service of the function app. Then we can continue and abuse the managed identity attached to the function app in order to read secrets from the key vault and to read blobs from storage accounts. And the blob will be a zip file with password protection that you can find within the function app. So we are about to end. Thank you everyone for joining today. Thank you. Any questions?
I'm assuming you've shared this with Microsoft Security, right?
So not really, because it's not an actual vulnerability in the environment. It's more of an abuse of different features that you can do within it. So it's really scenario based and related.
All right, last question is going to be up here on your left.
That was a great talk. A very eerily similar chain of attack in the Orca disclosure that they made back on April 11th, turning a list keys permission into remote code execution through Azure functions, and the MSRC was kind of like, yeah, that's by design. Why does this keep happening?
So I think that the main problem is that the cloud security teams are not really mature with their expertise, and usually whenever you will see an Azure environment, you will see that no one is really using that much the custom roles and customizing the different permissions that you can do. You're just usually giving an owner permissions, global administrative permissions, maybe contributor, which are really permissive and allow you to do many things. Most people are not really familiar with the impact of each one of the permissions that are there set in place, and you really need to be a real experienced in order to understand what will be the difference and the impact of changing those things. So usually the permissions are really excessive and you can do many things there.
I hate to do this, but we have to turn this room over for the next talk. So you are welcome to continue the
Yeah,
conversation
I will stay
outside.
here
But
and we can continue to talk.
absolutely. Again,
Thank you,
one more round of
everyone.
applause. Thank you so much.